Greetings and welcome, friends. Mr. Waddy here, and my favorite algebraticians are with me today. We are talking about section 5.7, systems of linear inequalities. We talked about graphing linear inequalities in two variables yesterday with like all the dotted line, solid line, shaded above, left, right, down, whatever. Today, imagine instead of doing one of those problems on a coordinate plane, what if we did two or more of those problems on a coordinate plane, and then the solution would have been like the common shaded region? It's going to be amazing. It's going to be gorgeous. You guys got your colored pencils ready? I hope so. Yeah, here we go. All right. A system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. So here I've got two sets of inequalities, and the solutions of this system would be the points in two variables, the x, y ordered pairs, right? X comma y. That is a solution of each inequality simultaneously, all right? There will be lots of points that are true for this line, and it's shaded half plane, and lots of points that are true for this line, and it's shaded half plane. But there will only be some of those points, although still infinitely many, that are solutions of both simultaneously. So let's first just explore that idea. Let's check whether the ordered pair is a solution of the system. All right, so I'm going to make this my blue line. And if I want to check to see whether or not 3, 5 is a solution, I'm going to plug 3 in for x and 5 in for y and see if it's true. So the question is 5 less than 2 times 3? Is 5 less than 6? Yes. It works for the first inequality. But now let's try it for the t'other inequality. It's got to work for both. All right. All right, what we're doing is we're plugging in for x and y, and we're checking to see if it works in both of them. Yeah, so make sure, ask your questions if you need to, or tell me where we're slipping. Let's see, so 5 for y, I'd have 5. Is that greater than or equal to x plus 1? And instead of x, I'm plugging in 3 plus 1. So is 5 greater than or equal to 3 plus 1 is 4? That is also a true statement. So since this point works for both of those inequalities, then it is a solution of the system. Okay? It's got to work for both if it's going to be a solution of the system. Let's try negative 2, 0. So we'll plug it into the blue inequality. So I'm plugging in 0 for y and negative 2 for x. So is 0 less than 2 times negative 2? Is 0 less than negative 4? True or false? Green or red? 0 less than negative 4? So this is false. And Kayla, what was your question? This point is applying to the same ones. Sorry. Right. So we were plugging negative 2 in for x, and we were plugging in 0 for y. Right? And it didn't work for the first inequality. Technically, I could end there, but let's just see if it works for the second one. I'll plug in negative 2 for this x and 0 for this y. So is 0 greater than or equal to negative 2 plus 1? Is 0 greater than or equal to negative 2 plus 1 is negative 1? Is that a true statement? Yeah, 0 is bigger than negative 1. That's true. However, just because it worked for the purple inequality doesn't mean it works for the system. It failed in the blue inequality. So this is not a solution of the system. Is not a solution of the system. Okay? It's got to work for both. Work for both. Ain't no good, just work for one. All right. So let's take a look at this concept of what if I wanted to graph all of the solutions, right? What if I wanted to represent them as a graph rather than, like, because I know how to check whether something's a solution, but what do all the solutions look like? And so the graph of a system of linear inequalities is the graph of all of the solutions of the system. All right, and a graph might look like this if you had two inequalities. So what I would do is I would have graphed one of these inequalities, right? Y is less than x plus 2, all right, like this orange dashed line here, and its solutions. Let's see if I can actually, I don't even know if this will help or not, but let's see if this helps. And so the solutions, because my shading doesn't show up great here, I'm assuming it doesn't show up well on yours either. So my solutions are all of the points below, right, that line. And in this case, because it's a dashed line, it does not include that line. So those are all of the solutions of that line, or that inequality. And then right on top of it, in the same coordinate plane, I'm going to graph the other inequality. Y is greater than or equal to 2x minus 1. So here's the line 2x minus 1. It's solid because of the equal. And to shade the points greater than it, it's going to be above the blue line. All right, so shade in the points, shade in the points. Hey, hey, shade in the points. All right, and I get that. So as far as where are the solutions of this inequality, it is the common shaded region. All right, so it's this slice down here, right? Right, it's this slice right here, and everything in between. It's what was shaded, what is the overlap between those inequalities. And the points that are just in the blue region would have been solutions of the blue inequality, and the points that are just in the purple region would have been solutions that are right to this, I guess, orange inequality, but I shaded it purple. And there are technically points over here, by the way. There's this point here would have been a solution of neither of those inequalities. So here's a region that's none of them worked. Here's a point where the blue ones work. Here's a point where the purple ones work. And here's a point where both of them would have worked. Okay? So that is the idea of the graph. So you graph both of them in the same plane and find the intersection of the half planes, and those are the solutions. So let's do this. We're going to have such pretty graphs, friends. Oh, boy. Are you guys excited? I'm excited. We're like coloring today. Ooh, colors. Colors. Here we go. All right, example dos. Graph the system of linear inequalities. The liniest inequalities. All right, so y is less than or equal to 3. I'll do some y is less than or equal to 3 work over here. Actually, let me make that my blue line. So, why is it? Why is it less than or equal to 3? All right, so yeah, tell me about this line. So y compared to a number is going to be a horizontal line. All right, looking at the inequality, because it's got the equal part, it will be solid. Because it's a y related to something, I know it's a vertical relationship that they're telling me y is less than, and vertically speaking, less than would mean below. All right, so let's graph this. All right, so y is less than or equal to 3 would be a horizontal line that passes through 3 on the y-axis. Or you could have just plotted a whole bunch of points that have 3 as their y-coordinates and gone from there. Let's see, let's get my full start line tool here. And it's a solid line, so I'll draw. Look at this. This line is solid. Solid. Right? And which way am I shading this? Below, because less than. Let's see. All right. So I'm gonna shade. You guys are shading. Don't color too dark, by the way, because I want to be able to see the overlapping colors. So don't. That's why you see I've got like semi-opaque little hash marks for my shading. Well, you might be able to outline the shaded region better. Well, but there's space in between it, so it can be dark as long as you've got gaps. All right, so let's look at this other line. So I've got. I'll rewrite it in purple just so we know who we're talking about. Y is greater than x plus 2. So that's conveniently already in slope-intercept form. Well, it's going to be a diagonal line because it's got the mx plus b. M is going to be the 1. The Y-intercept is going to be the 2. And let's see, analyzing this, looking at the inequality, you said it's a dotted or dashed line, right? Because it doesn't have the equal part. And it's greater than, which when saying y is greater than, y is vertical, that means above for us. Above. I'm so excited. Guys, are you excited to see what this is going to look like? You guys are all coloring. I know when I color or draw, sometimes I stick my tongue out of the... No? All right. You try sticking your tongue out of the corner of your mouth. You'll be surprised. It'll help you like draw better, maybe. That's what I did when I was in elementary school. So let's see. Y-intercept is 2. So here we go. Here's 2. All right, found it. The slope is 1. So up 1 and over 1 and up 1 and over 1 and up 1 and over 1. Okay, like so, like so. And let's draw my line. Okay, so I'm going to line them up. All right, so I got my ruler. And you guys said this is a dashed line or dotted line. Let's see how good my dashes and dots work out today. That's pretty good. I'm happy with that. Feel like I could make them a little larger, but that's fine. Right, so there's the dashed line. And now we want to shade it. Which way were we shading? Above the line. All right, so I'm going to shade... Yeah, so I shade above the line. Right, so my solutions are all of the points in the common shaded region. Okay? So my solutions, so you notice that there's an intersection right here at 3, 1. Now, 3, 1 actually wouldn't be a solution of the inequality, though, because one of those lines is dotted. All right? It's sorry, 1, 3. My bad. 1, 3. Whoa! Yeah, you guys always feel free to correct me if need be. But yeah, so the common shaded region, you guys can probably see is this area right in here, right? So those are all of the points that are solutions of my system. What do you mean? Right, well, but we only consider the solutions that have both colors shading, is what we do. And so a point over here was a solution of neither system. A point here was a inequality. A point in this area would have been true for the blue inequality, but not for the purple. And a point in this area, or this area, would have been a solution of the purple inequality, but not the blue inequality. So the only ones that work are ones like this. Let's see. Well, over 5 up 4, this would have been in a no solution region. Oh, so like, so yeah, -5, 3, this would be a solution. What about a point on this line? Because it's a dotted line or a dashed line, right? So yeah, hopefully the colors you guys are able to like make clear. If you wanted to outline your shape in a darker color or something like that, feel free to do that as well. I just think these look so pretty. Adorable, pretty, really quite pretty. So let's see. Let's make another one. Ooh, this one's interesting. Example 3. So this is claiming no solution. That's weird. Well, let's first get these into slope-intercept form. Both of these I'd have to subtract 2x from both sides. Let's see, so for the first one, I'll do that in blue over here. All right, so subtract 2x from both sides. I'd have y is less than negative 2x minus 1. And let's see, this one I, oddly enough, also had to subtract 2x from both sides. So why am I subtracting 2x? Can anyone tell me why I'm even doing that? Like what? And yeah, because it's positive, I got to do the inverse. But why did I even want to move? Why am I moving it? And I want that equation in what form? Yeah, slope-intercept form. So that's my goal. So that's why I was doing that, in case you guys were wondering. I'm putting it in slope-intercept form. And now let's analyze. Question? All right, yeah, it was weird. I did this top line over here and this one down here. And it's weird that they just happen to have the same exact first step. All right, so let's analyze the inequality. So this one is dashed, right? So it's a dash or a dotted line, right? And greater than, because it's a y inequality, it would be shaded above. This one is dashed and shaded below. I'm not going to label the whole slope and y-intercept. So if I'm graphing, let's start with the blue line. If I'm graphing this, the y-intercept is at -1. -1. And the slope is -2. So down 2 over 1, down 2 over 1, down 2 over 1. So let's draw that line. Now it's going to be a dashed line, so careful. Don't get too excited and then like suddenly make it solid. But if you do that, which I've done myself, right, just like make a solid line, and I didn't mean to, you could like just draw an arrow to it on a test or whatever and just be like, dashed, and I'll know what you mean and you'll get full credit, don't you worry. All right, so there's our dashed line. And which way am I shading this? Let's see, yeah, this was the blue line, so I'm shading below. All right, so shading below the line. Look at the blue, blue sky. All right, there we go. Yep. So let's see. Let's figure out where this purple line is. What's the y-intercept on the purple line? Anybody? Oh, y-intercept? I tricked you. I started with the y-intercept. So 3. All right, no worries. Okay, so there's 3. And what's the slope? Yeah, -2. So I'll go down 2 and over 1. Down 2 and over 1. Hopefully we're getting solid at drawing these lines. We're actually, next chapter, going to draw some nonlinear graphs. That'll be exciting. Hey, these lines are parallel to each other. Make sure they're dashed. Yeah, yeah, don't line up that ruler and then end up making a solid line too early. Oh, yeah, be careful. All right, and we said this is shaded above because greater than. Bless you, yeah. Yeah. And I'm shading above, shading above. So yeah, these are parallel lines. Yeah, bless you as well. And so they're parallel. There's like this no man's territory here, World War I style. So here's like the Germans and here's like the rest of Europe or whatever. Is there an intersection between the shaded regions? No. So this is no solution. There's no common points. All right. Now, if these were parallel and both of them were shaded below, we would have had a common set of solutions. But yeah, because these happen to be shaded in opposite directions, there was no solution. No solution. Let's see. Did I give you guys... Let's do one more, just because these are so pretty. Yeah, I don't know. Let's see. Yeah, these are nice. Let's do monitoring progress question 4. I think I gave you guys that one. Right, you guys got that. It's got the half slope in there. This one's nice. Lovely. Really quite lovely. Do you guys like the coloring? I'm actually, okay, graphing is my least favorite math when I'm not using technology anyway. And but I'm liking this today. I'm liking this. And like, I guess it also typically we'd get bogged down spending all the time creating just our grid. But the fact that the grids were already made, I think that helps. Let's see. So these are already in slope-intercept form. I'll make the first one my blue line and the second one my purple line. You guys got your own colors you chose. So let's see. Do you guys think we could do this without labeling shaded above, below, dashed, solid? Now, I'd recommend on a test that you would say, okay, like label, this is going to be dashed. This one is going to be shaded above. Because, well, then you could get partial credit. Because what if your graph is just completely wrong? But then I'm like, but they knew that. And then I'd be happy to give you points, you know? So yeah, so it wouldn't be a bad idea to label it. But I just want to point out we technically could do without. Let's see if we can do it without labeling everything. So the y-intercept is -3. And the slope for this line is 2, right? There's the 2. So up 2 over 1, plot some points. Let's get a few of them. Yep. And is this one a solid or dotted line? Because it's strictly just greater than. It doesn't say or equal. Let's see, so line up my ruler. Oh, I hear some good shading going on already. Nice. All right, so a lovely, lovely dotted line. And which way do I shade this? Above, because that's a greater than symbol, and there is a Y. All right, so here's my blue solution set, of which there are infinitely many, a half plane worth of them. All right, wow. I do like this little shading tool, etching style here. So let's how about the purple one? Y-intercept is at 1. Slope is a half, so I'm going to go up 1 and over 2, up 1 and over 2. You guys are so good at this these days, right? And let's see, we'll draw that line. Solid or dotted? Solid. Yep, because of the equal part there. Solid line. Is it? Above, because greater than, yeah. All right. A system of linear inequalities. And so, okay, so now that I've got it shaded, you guys are still shading, I realize. Question, is this point, -2, -2, a solution? No, it works for the blue inequality, but not the purple one. Is this point, -2, 0, a solution? Yes, because it's a solid line and it's in both of the shaded regions. How about this point right here? No, it's on the dotted line, and this whole region is a no-go, because that's just purple solutions. Yeah, so you guys get the idea. Lots of different lovely solutions that we have here, right? Lots of lovely, lovely solutions. Let's see. Oh, man. Ugh. Okay. All right, let's at least do example 4. I didn't realize we were going to jump into this today. I forgot about this part, but that's okay. Yeah. That's all right. We're amongst friends. Okay, so here is example 4. Let me shade this with some orange just so mine shows up. I'll just shade the common shaded region. So there's the common shaded region over here in case it doesn't show up that well on the screen. You could color your guys in as well if you want to make it look a little bit better. Yours shows up good enough? All right. So what if I want to write the equations that make this set. All right? So I've been given a graph, but now I want to say, well, what two inequalities would represent this? So let's talk about this horizontal line first. Oh, you're looking at this? Yeah. I actually don't need to know that point in order to write the system of linear inequalities, but that is an interesting point. That is worth knowing when talking about these. So if I want to write the equation of this blue line, it's a horizontal line, so it's going to be y compared to some number. And what number should I compare y to? Well, where is it crossing the y-axis? -2. So it's going to be y related to -2. Now, it's a solid line, so the relationship has to have an equal part underneath it. And it's shaded above this line. So what type of sign should this be? A greater than or equal to, right? Because it's shaded above, so greater than is what I would need. So there's my first inequality. Let's do the purple one. Actually, yeah, what is my, how good of a dashed line can I draw by hand here? All right, so there's my purple line. I dashed it a little bit. If I want to represent that purple inequality, that's a diagonal line. So that's going to be y mx plus b. What is the b? What's the y-intercept for this? It's crossing the y-axis at 0. So you could write +0 or just leave it blank. And what does the slope of this line look like? We'd find any two points that cross the grid, and it looks like it goes up 1 over 1. So the slope is 1. So it's going to be y related to 1x plus 0, right? Or you could have just said y related to x. Now it's a dashed line. So what does that tell me about what symbol is going to go here? Correct, right? It won't have the equal part like over here. And it's shaded below a less than sign. Less than sign without a equal part. So I could simplify that to just being y is less than x. And actually, I could even just write both of them together. Y is less than x is the system, right, of inequalities. Let's actually graph this using Desmos Grapher. I don't know if you guys knew this, but Desmos can graph inequalities in a really beautiful way. All right, here we go. So my first inequality is y is greater than or equal to -2. So watch this. I'm going to do y. I'm going to do greater than sign. And then hit equal sign. And watch what happens. You guys watching this? Bam. I hit equal sign, and it actually like combined them into a single symbol. And then -2. And notice that it actually graphs that whole half plane for us, like so. All right, and the other one was y is less than x. All right, so I'm going to write y less than sign x. And notice it even gives me the dashed line and the shading, and you can see the common shaded region. And that does appear to be a match to the graph that they gave us, right? Yeah, there's I could continue to zoom out and see, you know, all of the solutions that work for it. Yeah, so that's pretty cool. That's pretty cool. Let's see, where am I at here? That's not what I was doing. There we are. So I don't know. Let's see. I think I'm good. Huh. Yeah, I think I'll skip examples 5 and 6 and give you guys time to work together. All right. So yeah, we'll cut it off from here. Thanks for watching, internet friends. Bye-bye.